Wow. I was moments away from asking folks to sit on each other's laps. Guys, good evening. My name is Zach. I am the Director of Education at Florida Oceanographic Society, and it is my pleasure to welcome all of you to the first installment of Florida Oceanographic's 2020 Coastal Lecture Series. Now, I have to tell you, last year broke our all-time attendance record for the Coastal Lecture Series. I want you to talk to your friends and neighbors and help us break that record again this year. I'd love a full house like this for every single one of our upcoming lectures. We have 8 exciting lectures scheduled over the next 3 months, all of which focus on unique stories that are important to our part of coastal Florida. So since we have a captive audience tonight, I'm going to go over the actual schedule real quick. I don't know if there's any left in the back, but there might be some of these in the back of the room. At the end of the night, if there aren't any left, go on our website. You can print out a full copy of this year's schedule. So we're going to have local historian and author Sandy Thurlow give us a glimpse back in time to see what South Hutchinson Island used to look like before we built houses and condos everywhere through her incredible archive of black and white photography. We have Dr. Ellen Prager, an internationally recognized marine scientist and author, who's going to talk to us about some of the ocean's weirdest, oddest, and most important creatures and why they matter. We have Dr. Michael Grace, Professor Emeritus at Florida Institute of Technology. He is a guru on vision. He's going to talk to us about vision and some of our favorite marine animals, including whales, and how marine vision might shed some light on human visual disorders. We also have Eric Alt from the Florida Fish and Wildlife Conservation Commission. He's going to give us an update on ongoing research that's being conducted in our area about fish and wildlife, with a specific focus on game fish, things we like to go fishing for. Dr. John Moore, who's a professor at Florida Atlantic University, is going to give us a wonderful story about the impacts of the Deepwater Horizon oil spill on very unique organisms that live thousands of feet below the surface of the Gulf of Mexico. And then finally, Dr. Stephen Kajura, also a faculty member at Florida Atlantic University, he's going to tell us about those thousands of black-tipped sharks that show up in our area every winter. Fascinating stories. So grab one on your way out. If our stack is empty, which I'm guessing it might be, again, check our website. Our next lecture is 1 week from tonight. So a week from tonight, next Tuesday, the 14th, we'll feature Mark Perry, the Executive Director of Florida Oceanographic Society. Anybody know Mark? So while Florida's waters have had a few rough years in a row, 2019 showed us a couple of positive signs. We're moving in a good direction. Mark's going to give us an update on the health of our local estuaries, as well as the overall progress on efforts to fix Florida's bigger water issues. Next week is one you're not going to want to miss. So again, grab a schedule on your way out or check our website. I want to remind you, we're going to be on Tuesday nights throughout the season this year, not Mondays, Tuesdays. It's not every Tuesday. It's kind of scattered between now and March, so definitely check the website for exact dates. Now, I know most of you have already signed up for our email newsletter. You get our once-a-month reminder of what's going on in FOS. If you haven't, there is a sign-up sheet on the back table. I would love you to sign up and join our email newsletter. It's a really nice way to stay in touch with our organization and find out what we have going on. Speaking of upcoming events, we are running special guided beach walks on Sunday mornings between now and the end of February. It's a neat opportunity to get a little bit of education about our local beaches. If you're interested, stop online. We can tell you more about the events, and you can also register. Now, tonight's special guest speaker, John Englander, is an oceanographer, an author, and a leading expert on sea level rise. For over 30 years, John has been a leader in both the private and nonprofit sectors, serving as CEO for such noteworthy organizations as the Cousteau Society and the International Seakeepers. He's a research fellow at the Institute of Marine Sciences at UC Santa Cruz and a fellow of the Institute of Marine Engineering, Science, and Technology. John's broad marine science background, coupled with firsthand experiences in Greenland and Antarctica, allow him to share the big picture story about sea level rise and its impacts on society in a way that's clear and understandable. He has briefed numerous governmental agencies on the impacts of sea level rise, including the U.S. Coast Guard, the U.S. Air Force, the Department of Homeland Security, a Congressional House Subcommittee, the Joint Arctic Command, and the Center for Military Studies at the University of Copenhagen. John's best-selling book, High Tide on Main Street, details the science behind sea level rise, as well as the potential economic impacts that we're probably going to be dealing with in the near future. Copies of John's book are going to be available tonight out in the courtyard, just outside of these two doors. John's going to do a book sale and a book signing. We have to leave the theater in time to get the library closed up, so we're going to take that book signing right outside. If any of you are interested, I'd highly recommend checking this out. And with that, it is my greatest pleasure to turn things over to our speaker tonight, John Englander.
Great intro. Really well done. Thank you. Thank you, Zach, and thank you, FOS and the Blake Library. I live in Boca Raton, so this was an easy trip. I get to do talks all over the world, from London next week and Singapore and lots of exotic places. It's nice to have a warm welcome and introduction here close to home. I try and orient the talks to the different audiences. If I'm talking to engineers or architects or military people, intelligence communities, their interest is different. So you're a general audience who's interested in the oceans, obviously, and you live near the ocean. And we're in that state that's probably thought of as most vulnerable to sea level rise. But we'll talk about that and try and understand some more about it tonight. I'm going to talk for about an hour and leave at least 15, 20 minutes for questions. Any question regarding sea level rise and directly in that area is fine. And then as Zach said, I'm going to be outside, and a colleague of mine who's the guy wearing the blue sports jacket here, Turk Lewis, is going to help me selling books, and if any of you want some more information about what I'm doing. You probably don't see many icebergs here in Stuart, Florida, I take it. How many? I think it's safe you're not going to be seeing icebergs here. How many have ever seen an iceberg? Wow. I guess Alaska, probably most of you. How many Greenland? Dozen or so. Antarctica? Not movies. I mean, not movies. Okay. This photograph was taken by one of my group on an expedition we did in September. I'm going to tell you about another trip we'll do next August, and there's room for a few of you to possibly participate in that. But you can tell from this iceberg, not only is it large, it's probably about the size of this building, but it's freshly cut from a glacier. You can see sharp edges. Icebergs come in all shapes, sizes. Some of them have flipped over, but if you've been around a lot of them, you can begin to discern some characteristics. Now, sea level rise has an interesting connection with icebergs and glaciers in the Arctic and Antarctica. How many of you are aware that icebergs are melting faster than ever? Right, most of you. And how many of you would think about sea level rise when you see icebergs melting as kind of cause and effect? Okay, well, that would be fictional. That's not true. And we'll get into that in a minute. But it's an example of, it was a trick question because most people think that melting icebergs add to sea level rise. They don't. You'll understand that perfectly well in about 10 minutes. Okay? But the point is, there's some really basic things about this planet. All of us are interested in oceanography, the study of the oceans, which can be everything from coral reefs to sea turtles to fish to algae blooms to coral reefs, et cetera, to more esoteric science. But the breadth and depth and complexity of that boggles the mind, and nobody can understand it all. What I want to talk about tonight is just about sea level rise, which will touch to climate change. I'm not going to get into all the other marine issues like algae in the waterways and fish die-offs and what's happening in Lake Okeechobee. That's not our topic tonight because we have a lot to talk about in 1 hour to understand sea level rise. The interesting thing about sea level rise is that it's sort of more about the land than it's about the ocean. I mean, there are ocean impacts as the sea is going to rise, but the first implication of the sea rising is that as the water goes higher, the shoreline wants to move inland. So counterintuitively, kind of, or ironically, the real impact of sea level rise isn't on the sea, but there are impacts, but it's really on the land where we live, our cities, our houses, our businesses, our countries. And I'm going to show you the history of sea level rise in a big picture view that you've probably never heard before, because I've given now 300 talks in 7 years, and I don't think anybody has ever left the room and say, wow, I never saw it that way before. Okay, any of you happen to do the Twitter stuff? I'm at John Englander. It's real simple, both as a way to track this and also communicate if you need to later. What I'd like to cover tonight is clear up the confusion, talk about flooding and erosion as well as sea level rise, which are certainly interrelated to some degree. I want to explain sea level rise, and I'm going to do it from the standpoint of Greenland and tell you why, because it's the big factor. Talk about our Rising Seas Institute. We have a 501c3, and we're glad to work with groups like Florida Oceanographic Society and others, as all good nonprofits do. We like to collaborate. We're in a bigger mission, and the ocean is about as big as it gets. And of course, I want to answer your questions. There's lots of words we throw around: sustainability, resiliency, obviously climate change, global warming, and sometimes the words are helpful and sometimes they're confusing. And so one of the things I'm going to ask you to do with me is to kind of work with me on defining the terms a little more narrowly than you might do, because thinking about adaptation as if it's sustainability and resiliency is not a good idea. We need to kind of distinguish those thoughts. So just to warn you up front that I'm going to give you some different definitions perhaps. Let's start with coastal flooding as the big picture issue that's going to bring us to sea level rise. The three things in white: storms, rain, and runoff, are weather-related events. You all know that. They're hard to predict when they're going to happen. We don't know the magnitude. We don't know exactly when, where, and how strong any of those events will happen, but we're used to that. Nobody doubts that. Extreme tides are part of the natural tide cycle. We associate that with they said I can move around a little bit up here, which I like to do. I need to stay within the lights, apparently. Extreme tides, you all know, are related to the moon cycles. And at the full moon and new moon, the tides are higher. And that actually follows a 19-year cycle, giving us what we call king tides, when the planets are closest and the pole on the oceans are greatest. But what's been happening in the last 10 or 20 years is those high tides keep getting higher. Now, the moon's not getting any bigger. The moon's not getting any closer. It's that we're adding more volume to the ocean. Sea level's rising like a drip filling the bucket. And we talk about it, but we really don't understand it, because like a drip filling the bucket, it's really hard to visualize. And we tend to look at the big events, the storms, the heavy rainfall, the runoff downhill, and we see it at the king tides. The high tides keep getting higher, but the real culprit that's changing the baseline is sea level rise. And then coastal erosion is another thing that gets tossed in as the same kind of issue about coastal land going underwater, but it's really quite different. And in fact, let's start with that one. We all know what coastal erosion is. That's quite a natural process. Coastlines have always migrated, and it happens worse during a storm event when the hurricane waves are kind of clawing at the beach. But even without a hurricane, and even without any of those other effects, coastlines would always migrate. That's what they've done. We just were kind of dumb to build these big buildings right up close to the ocean because we want to be near the beach, right? And thinking that somebody's going to insure it or pay for it if we get eroded. Or we can pump the beach back where we want it, which is a pretty expensive undertaking. So let's kind of go over the other issues. We'll set aside erosion for now because it's quite different. It gets confused with sea level. But we know storms. Hurricane Sandy 7 years ago. Superstorm Sandy hitting New Jersey. This people tend to remember in Fort Lauderdale the weekend that 4 blocks of A1A washed away in front of the hotels in Fort Lauderdale. Most people sort of think it was Sandy. It was a month later. It wasn't even a named storm. Now, those storms are having worse effect because sea level's raising the water level. Also, we're tend to get stronger storms as well because of climate change. But I want to help you detangle all this so that we understand sea level rise, what's causing it and where it's headed. This is Stranahan House. If you've ever been to Fort Lauderdale, it's probably one of the most famous historic structures. It's a 100-year-old house, authentic in Fort Lauderdale on the river. When they built that house 100 years ago, the dock and steps didn't go underwater like that. Oh, turn your phones off, please. I guess I should have said that up front. So what's changing? It's sea level rise. After thousands of years of stability, I'm going to show you. And it's not just Florida. This is San Francisco. I bet a lot of you have been there, the Embarcadero. Show of hands, right? Most of you? Well, that's been there 140 years, and they don't have subsidence or uplift of the land. The land's been stable as it is in most of Florida. Some place in the world, the land's going down or going up, which confuses the issue. But in San Francisco, it's actually unchanged vertically. But 140 years ago, the water wasn't coming over the seawall. And actually, it's only been a problem for about the last 20 or 30 years. Again, it's sea level rise. Because those aren't really waves, that's just bay chop because of the Golden Gate Bridge throttling any waves coming in from the ocean in Alcatraz Island. So the little wavelets coming over the shoreline or the Embarcadero there are really doing it because of sea level rise. But nobody sees that day to day because you don't associate that. Where's the tide cycle at? Is there a low pressure system in the area and all the other variabilities? Okay, this is a street, happens to be in Fort Lauderdale, but it could be in any coastal community. A couple of strange things here. There's a truck on the right, which kind of indicates there must be a driveway nearby. There's boats in the distance, and a no wake sign in the middle of the street. What's wrong with this picture? Now, this happens regularly, so the city and the residents want a no wake sign so that cars don't drive through quickly and splash salt water and cause rusting on the cars. But then as soon as the full moon high tide, the king tide, has subsided, they want that sign taken down so that if they go and try and sell their house to somebody, the buyer doesn't say, why do you have a no wake sign in the middle of the street? So they hide them very quickly. It's funny and it's also crazy. That's the world we're living in at the moment. The water's getting higher. We don't understand it. We don't want to understand it, frankly. And it's never happened in human history. There's storm drains that back up that were designed to take excess rainfall and take it to the canal. Now the canal comes up during the king tides and puts salt water on the streets. Okay, I don't expect you to read this graph, but the point is that the 4 counties of South Florida, so everything south of here, Palm Beach down to the Keys, work together and agree upon what's a sea level rise projection. And they have different curves here and a little table. I'm just going to net it out for you. They say over the next 30 years, we could have a foot or two of sea level rise. And by the end of this century, 80 years from now, or if you want to go out 100 years from now, the year 2120, we could be looking at up to 8 feet of sea level rise. That's their prediction, not John Englander's. I think they're right. I think it actually could be a little bit worse than that. It's a sobering thought. I want to make sure you understand why that happens, what the variables are, what some of our options are, and how to educate other people. The fact that you're here tonight on a delightful night and the room is more than full. In fact, we're probably past the fire code or something like that. No, of course not. Sorry, I shouldn't have said that. There's an easy way to get out of this building. But there's over 300 people here tonight. Apparently that's a record. This is a hot topic, no pun intended. People all over the world want to find out more. I'll be in London next week. Something different is happening. So I'd like to break down what we think of as climate change into 3 subjects. One is sustainability. And that tends to focus on how to reduce the warming, which means reducing the greenhouse gases, sometimes abbreviated as GHG. And the primary one, as you probably know, is carbon dioxide, which was proven 160 years ago to trap heat, demonstrated in a laboratory setting in public in London at the Royal Institution by John Tyndall. It's easy to prove, actually. There's no doubt that carbon dioxide traps heat. It's a very potent greenhouse gas. Works like the sheet of glass in a greenhouse. So we need to try and slow the warming, and there's lots of good effort to turn to renewable energy and do things that will try to slow the rate of warming. And anything I can do to encourage that, absolutely. If we don't take our foot off the accelerator, this car is going to hit the wall a lot faster. In other words, we've got to slow the warming down is what I mean, right? So that's sustainability, something we can keep doing without degrading the resource, like not using fossil fuels. We need to do something that's renewable for the world's growing population. We're at 7.6 billion people. Most experts think we'll get to 10 billion people by mid-century. So even if we're more efficient with our energy and get carbon dioxide out of the atmosphere, with more population, we're still going to have a problem of warming. But as I'm going to show you in a few minutes, even if we could stop the warming, we're still going to have sea level rise. So that's probably my kind of first takeaway that you really didn't want to know. That no matter how good a job we do with our environmental efforts and how good a job we do at being sustainable with things like renewable energy, which we should, we still are going to have to deal with sea level rise. So that's kind of one of those unfortunate truths you're hopefully going to take away tonight. We have to work on sustainability. We have to be more resilient to events like wildfires, like Australia at the moment, but California and everywhere else. Extreme storms like Dorian a couple of months ago, the hurricane that wiped out the northern Bahamas. We need to be more resilient to events. Flooding is an event. Sea level rise is different. Sea level rise is a change in baseline. Sea level changes hundreds of feet by nature. What I'm going to help you understand tonight is what's natural and what has come from human impact. But I'd like you to leave here with a new vocabulary of thinking about sustainability, resiliency, and adaptation. Those, to me, are three very different things. I work on all of them, but I don't confuse them. Okay. Give you some context. The idea that the seas are rising isn't something that just popped up this year. This was from 2012, cover of National Geographic magazine. It had been talked about 100 years before that. They showed how high the water would be against the Statue of Liberty if all the ice on the planet melted. It would be 212 feet higher. Now, the truth is, you probably saw that cover. You probably forgot it. You know why? Because you wanted to forget it. It's true. This is one of those things you'd rather not know. Right? We tend to think of the melting Arctic for good reason. The polar ice cap's been there for a long time, actually about 3 million years. It's melting. It endangers one of our favorite marine mammals, the polar bear. And that's a good emotional hook for a lot of people. We could talk about that, but we're not going to get into that tonight. As the Arctic goes from bright white, which reflects light like a white roof on a house or a white car, to the darker, let me back up there, to the darker water, which is almost black, it'd be like taking a white roofed house and painting it the color of the water. Your heating bill would change, your air conditioning bill, right? Because your roof would absorb more heat. That's what's happening up in the Arctic today. Because as the Arctic ice cap melts around the North Pole, well, it endangers the polar bear, which I'm concerned about, as I'm sure many of you are. But the implications for the temperature of the planet and sea level, which we'll get to in a second here, is profound. Now, back to our icebergs, as I said up front, there's icebergs melting faster than ever. Like ice cubes in a glass pictured there, if this was clear you could see it, but you can do this experiment at home. As long as the ice cubes are floating in your glass, draw a line and let the ice cubes melt. The level will not change. The reason is, I like to teach science really simply in a way that not only I'm sure you could understand it, complex science, but I want to give it to you in a way that you can teach it to others. So even if some of you might intuitively know that, here's the simple answer. Ice is a peculiar compound, H2O, water. Just before it freezes, it expands a little bit. Ice is 9% less dense than water. That's a very peculiar property of the water molecule. But it's the reason that ice cubes and icebergs float about 9% above the surface. It's a simple fact of physics. So as the ice melts, it compresses a little bit. It gets smaller. It takes up the same space as the imprint of the ice underwater. Does that all make sense? Okay, so because ice is less dense, it sticks above the surface about 1/10. And that's why ice cubes and icebergs stick out of the water. But as they melt, there's no effect. Now, I'll come back to what does cause it in just a second. We're going to talk about the ice on land to kind of give away the trick here. But let's first look at what's happened with sea level in the last century or so. We've been keeping records from tide gauges and sharing them around the world since about 1850. And that graph shows the global average change in sea level, as best we can reconstruct it, from the tide gauges and making various adjustments for technicalities, and then in the more recent 25 years, the satellite era, which is much more precise. But sea level as a global average has risen about 10 inches, about 20 centimeters. And I just round numbers off. The precision of the number isn't important. They're all defensible, and we can get very accurate if you like. But I like you to remember concepts as opposed to something really technical. Not only for yourselves, but to be able to teach it to others. Most people shy away from lots of numbers and jargon and graphs. So I make it as simple as possible. And I'll tell you how to get my graphics at the end as well. I'd love you to use this and teach others. If we take the satellite era, the last 25 years, and blow that up, since 1992, we've had satellites that do really precise radar measurements, radar altimetry of sea level, down to fractions of a millimeter, hundredths of an inch. It's amazing technology. And it's much, because the satellites are going around the Earth every hour and a half, we have a lot more consistency of the data gathering and can do corrections and things like that. But what we know is that since 1992 here, the rate looking backwards was about 1.5 millimeters. Now that's about a 20th of an inch. I mean, it's really fractional, okay? But in the next period of time here, from 1997 to 2011, the rate more than doubled. It's 3.2 millimeters a year. That's about a 25th of an inch. And again, it's irrelevant, frankly, the exact number. But the big factor is, look at the rate of increase. In the last 8 years, it's 5 millimeters a year. That's effectively doubling, 1.5 to 3.2 to almost 6. That doubling is like super compounding of money, if you want to think of it like that. You know how money compounding can get away from you, either if you're a borrower or hopefully a lender. Compounding has great effect. Exponential growth, doubling times. It surprises us. That's about to start happening with sea level because it's entered the early phase of exponential growth. But right now it's only 5 millimeters, which is just under 1/4 of an inch a year. So we tend to ignore it. We're waiting for the next big hurricane. We're waiting for the king tide. We're concerned about the heavy rainfall and coming downhill, right? All of those other forms of flooding. The sea level rise is like the drip filling the bucket. Who cares? But overnight the bucket will be full, right? Okay, if we go back in history, we get some real clarity. 20,000 years ago was the peak of the last ice age. There were ice sheets covering the northern hemisphere, a mile deep. As that ice melted, and you've all heard of the ice ages, right? Okay, so as that ice melted, sea level rose. And how much? 390 feet, almost 400 feet. That's mind-boggling, isn't it? When I learned this in college, I'll tell you, my path here started almost 50 years ago when I studied geology or marine geology in college, and I learned about the ice ages, and at that level of doing it in college, they pointed out that it was 400 feet vertical change with the ice ages. Well, I was working as a diving instructor over in the Bahamas at the time during my summer holidays from college, and I actually found an ancient shoreline 200 feet underwater. And I took samples back to my professor in Pennsylvania, and he said, oh yeah, that's 15,000 years ago when sea level was down 200 feet. That made an incredible impression on me in the early 70s. I didn't think it would change in my lifetime, but I parked that thought. And every time I've done thousands of dives. I've been in submarines fairly deep and I've been diving into the polar ice cap. I was always looking around for evidence of ancient shorelines. But more for historical context. Again, I still didn't think it was going to change in my lifetime. And then in 1997, I had a big dive operation in the Bahamas by then, and was successful, and I was running a program for the diving industry, and we had an annual conference in Orlando, and we got Jacques Cousteau to come over. Most of you can probably remember Jacques Cousteau, right? Yes, okay. So Captain Jacques came over, and I was the chairman of this group, and I got to give him an award, but we spent 3 days together in the hotel in Orlando, and it changed my life, not in any way I'd ever expected. He was 86, his son Jean-Michel was there. They were having actually a quarrel at the time. A legal dispute, unfortunately. It was really sad. And I know, because Jean-Michel was a good friend. But by the second day, Jacques turned to me and said, I don't suppose you'd help me run the Cousteau Society. Something I'd never considered in my wildest dreams. But I said, what do you mean? And he said, well, I need somebody to take over. I actually, it just came back to me. The air went out of the room. But I said yes. I hadn't thought it through very well. I had to sell my business. I couldn't be in the diving business and run the Cousteau Society, but I did that. But a month later, he was in the hospital. 3 months later, he was dead. We had his funeral in Notre Dame, and again, I try and talk quickly over this because I'll get emotional, but in spending 3 days with Jacques in Orlando, aside from the ceremony where I gave him an award, we talked about how the world was changing. And we talked about how to communicate. And he was as good as it gets. But the 3 takeaways I remember from the long discussions with him: we have to help people connect with the ocean. We need to simplify the complexity of the ocean issues so people can understand them, because it's just too complex for anybody to absorb the sea in its entirety, obviously. And if we're going to communicate, let's not only keep it simple, but let's find emotional things that grab people, and probably with visualizations. And of course, he was the master of creating the undersea world of Jacques Cousteau, the TV series that most of us probably were our first glimpses of the underwater world back in the 60s and 70s, and now he's got 7 progeny, children, grandchildren, nieces and nephews all around kind of carrying the message. But Jacques was unique. So when he died, his widow wanted to get rid of me, which is his second wife, and which was fine. She bought out my contract. And I had 9 months off, kind of a sabbatical. I'd sold my business. I'd moved to Virginia. We had an office in Paris, New York, and Virginia. And I had to decide what to do with the rest of my life. And that summer, there was a lot of talk about climate change. And I wasn't sure I understood it. So I started keeping a notebook. I recently found the notebook, is why this is all so clear to me. I'd forgotten about it. But I came across it in my garage the other day, and I was gathering articles about climate change, trying to figure out what's human-caused and what's natural. And it was still kind of a journey of discovery. That was 1997, the year he died. 10 years later, I was in Greenland. I was running a group called International Seakeepers, some very wealthy yacht owners, and got to take them on some little expedition-type things to learn more about the oceans. And the first night in Greenland, I got this epiphany. I said, wait a minute, the world's warmer, we've measured that. The ice is melting, we're going to see that tomorrow. If there's less ice on land, the sea level will be taller. That's like adding another ice cube to the glass, or pouring water into the glass. And if sea level's higher, the shoreline's going to try and move inland. I said, those 4 points are pretty simple. And because they're going to affect people regardless of their political beliefs, and they don't need a science degree to understand that, I think if I could tell that story, that it would help communicate this problem. And that actually is what led to my writing High Tide on Main Street. It took me 4 years to kind of figure out the science and put it into stories that anybody could understand. But that was the big next step of my journey. So that was step 3. First was seeing sea level 200 feet underwater, or in the beaches, back in the 70s. Then Cousteau and the discussions, then kind of my epiphany night in Greenland, which led to me writing the book. And then it took me 4 years, but it came out October 22nd, 2012. Anybody know what that week was? Hurricane Sandy. And somehow on page 121 of my book, which published on the 22nd of October, I described a superstorm hitting New York City and Atlantic City, which happened a week later. So I got on television. Mr. Englander, how did you describe or know about Hurricane Sandy a week before it happened? I said I would have had to know about a year ago when the book was written. It was a coincidence. I was describing a scenario of what could happen, but it did get me on television. It began my speaking career. So that's my journey of how I'm here. So let's go back to the Ice Ages. Sorry, I go way off on subjects. We could talk for a few hours here, but they're going to throw us out at 8 soon. Sea level did not rise smoothly. There's 3 things I want you to get from that graph of how sea level rose since the last ice age. It rose almost 400 feet. It's not a smooth line. It's not a smooth curved line. There's some bumps in it. That's how the ice sheets collapse, which is the source of that. I'll explain that in a minute. That was a really bad sentence, but I think you get the idea. Don't expect sea level to rise smoothly. It never has, it never will, over the long term. What's at stake here is that we're at the 30th floor of the building. 20,000 years ago, not that long ago, when you think about it, like Christian era is 2,000 years, Mayan, Jewish, and Chinese calendars go back 5,000 years. 20,000 years ago, the planet was covered by ice. And sea level was 400 feet lower. It's mind-boggling. The reason we don't know that is because about 5,000 years ago, it got to the present level. Sea level hasn't changed much in 5,000 years, all of human civilization. We didn't even understand the science till about 150 years ago. So we built up on the shoreline, and we had these tales of cities of Atlantis and things like that, about cities going underwater, and they're all over the world. In fact, it turns out that that's happened because people were around 13,000 years ago when sea level was rising at a rate of 1.5 feet a decade by nature, without human intervention. Isn't that amazing? I want you to start teaching this when you're done, is why I hone in on some of this stuff, and I'm serious about that. What's happening here? Wrong direction, sorry. No, let's go back here. I got it, okay. Now, I know you've all studied the Ice Ages. If you saw part 2, The Meltdown, how many of you watched this? Okay. It's okay. It was a kid's cartoon, but it was really good. I watched this 40 or 50 times, not because I was studying it. My daughter was 6 the year this came out, in 2006. And behind Manny, Diego, Sid, and Scat, if you remember the names, there's 2 miles of ice over North America, and Asia and Europe, actually, too. And as that 10,000 feet of ice, just round off the figures, 5,000 feet in a mile, 3 kilometers, as that ice melted, retreated northward, sea level rose about 400 feet. 10,000 feet of ice turning into 400 feet of sea level. Does that make sense? Believable? Is there anybody in this room who disputes that science? No, I'm serious. No, okay, good. So we're together on this. So the ice ages are real, and that's why we know that sea level change was a natural cycle for a long time. Florida illustrates this beautifully. We all know the shape of Florida. Everybody in the world knows the shape of Florida. 20,000 years ago, Florida was twice the size because sea level was 400 feet down. 120,000 years ago, Florida was half the size because sea level was 25 feet higher. Now, the same thing happens in all coastal cities, but Florida is really illustrative because it's fairly flat and the big peninsula. So let's get into what's the problem and what do we need to do about it. This is a graph that'll be in the set of graphs I'll tell you how to, or charts I'll tell you how to get at the end. It's one I've put together with the help of a really famous climate scientist, Dr. James Hansen. If you've been reading about climate, you may have come across his name. This chart shows carbon dioxide in green, a greenhouse gas, global average temperature in red for heat, and blue is for sea level, okay? Again, I know a lot of people don't like graphs, and they kind of turn off to science, but I think you'll agree this is about as simple as it gets. And what I hope you take away from this is that in the 400,000 years shown here, if we start with the red line, I see some of you nodding your heads already, you get it, but let me talk you through it. So the red line is the ice ages. We've had ice ages for 2.58 million years. That's not an approximate number, as you can tell. That's how long we've been having ice age cycles, the Pleistocene, or we're in the Quaternary, as geologists would call it, but forget the technical names. We've had ice ages for just over 2.5 million years. A natural cycle. Man had nothing to do with that. The difference between the warming and cooling phase of the ice ages is 9 degrees Fahrenheit, 5 Celsius. That's what's shown there. It's a repeating cycle. The cycle's between 95 and 125,000 years. I don't have time to get into it, but it's in my book, and you can look it up. It's called the Milankovitch cycle. It basically has to do with the shape of the orbit around the sun, a little more heating and cooling. It's like a super summer and winter. So that's the ice age cycles, and I'm only showing 4 cycles here. There's actually, instead of 400,000 years, there's 2 or 3 million years to the left, okay? I'm showing you the 4 cycles because I can show you more detail. But the pattern would be the same going back 2 million years. Again, it comes because of this super summer and winter, we'll call it, which is the ice age forcing. When the planet gets warmer or cooler, the ice sheets change size. The ice on land as well as the floating sea ice. And that changes sea level. One has to complement the other. And so sea level peaks when temperature peaks. And carbon dioxide and temperature go together for 2 different principles. Either one can go up first, the other will follow. The principle that carbon dioxide traps heat, so when the green line goes up, it raised the planet's temperature over a period of centuries, was demonstrated in 1859. When the planet warms by the ice age cycles, it releases gas from the ocean, so CO2 goes up. And that's probably the most confusing aspect of climate change to most people is, well, which one's in charge, carbon dioxide or temperature? And they say, you can't have it both ways. I say, oh, yeah, yes, you can. There's 2 different principles of physics at work here. But they'll always go together. It just takes centuries to adjust. And that's what's confusing us. The problem is, as you can see, we've had 4 ice age patterns on that chart. The peaks all line up. It's a repeating pattern. We were at the high spot, and we probably would have been entering the next 80,000 years of falling sea level, falling temperature, falling carbon dioxide, and a cooling planet. But there's this circle up here, and CO2 is shooting upward like a rocket. It's gone for, instead of its natural range between 180 and 280, it's now at 410. And increasing faster than ever. And in spite of us buying electric cars and bicycling to work and composting and doing all the other good environmental things we'd like to do, we do. And we should do more of them. Make no mistake. The planet's warmer, and until we can get this carbon dioxide down, sea level rise is not going to even slow down. Now, it's slow enough that actually we can get ahead of the curve and begin adapting. That's the message you haven't heard, I would suspect. So why is sea level rising? It's because of the glaciers on land. You can visualize that as this glacier breaks off into a new iceberg, that's like adding a new ice cube to the glass of water. That will raise the level of liquid, of course. And where meltwater comes from land, from the glacier or pouring more water in the glass, it of course will raise the level. So adding ice from land or adding meltwater from land to the ocean, that raises sea level. The third reason that ocean level changes is because of what we call thermal expansion of seawater, but I can break that down too, although you could probably figure it out. As the ocean warms, it very slightly expands, like most substances, like roads in the summertime or runways. They buckle because they get bigger under a lot of heat. Well, the oceans being a degree and a half warmer already, they're a few inches taller just because of thermal expansion. And that'll continue, but it's going to pale by comparison to the ocean height added by ice entering the ocean as a new iceberg or meltwater from the ice on land. The problem is Antarctica on the left and Greenland on the right. That's 98% of the ice on land. The first sentence of my book says, if all the ice melts, sea level will be 212 feet higher. It's not going to happen this century. It won't happen next century. The truth is, it's almost a red herring to even discuss that. If there's no ice on this planet, I don't think we're on this planet either. We need to stop the melting, which is caused by us. But we also need to wake up to this reality that the sea level is rising. You've probably seen photos of these ice shelves. This is Antarctica in a really prime spot. But probably counterintuitively, or what you might suspect, or maybe you've already figured this out, because this ice, compared to the glaciers back on Antarctica there, this is floating on the ocean. It's a flat ice shelf. And that ice shelf behaves like an iceberg because its weight is supported by the water. So it's about 100 feet above the surface and about 900 feet below the surface. Now, as it calves off into a new iceberg, which is about to do here, and you've heard this in the news, you know, a giant A68 iceberg is calving off and it's 100 miles long. I mean, that's significant events, and it bespeaks the fact that Antarctica and Greenland are warming and changing, but the calving of a new iceberg from an ice shelf doesn't affect sea level. So this is kind of nuanced, I know, but I just want to kind of cement the science I've taught you already, that it's a melting of an iceberg has no effect if it's already been floating. It's when the iceberg breaks off a glacier and enters the ocean that adds to sea level. If the iceberg breaks off an ice shelf, it doesn't affect sea level. That's a little sophisticated, but just take it if you can remember it. If we look at that ice shelf in cross-section, though, I think a couple of interesting stories come to pass. The glacier, which can be like 100 miles long. In fact, the glacier that they're talking about here is about the size of Florida. Literally. And as the glacier's eaten away underwater out of our sight, it's happening faster, actually, than the melting on top. You can see icebergs there, and we got the floating ice shelf, and then the glacier on land. So I think you've got all the pieces of that. Here's Greenland juxtaposed against the eastern United States. It's unbelievably big. Greenland is about the same size as from Maine to Miami, and from where we are to the Mississippi River. Covered by a mile of ice today. If Greenland melts entirely, we have about 25 feet of sea level rise. That was another photo from one of our little fact-finding expeditions. We get helicopters, go out on top of the ice sheet. It's an amazing, eye-opening, memorable trip. It will make you think differently about what's happening in this world. We take our significant donors to the Rising Seas Institute, our admiral-level donors. If you want to find out about going on the trip, there's still 5 or 6 places left for August. Turk can help you with that afterwards, or I can as well. We have a new brochure out. It's August 11th to 17th. It's obviously not a trip for everybody, but we've got a writer from the New York Times coming, actually a very prominent writer from the editorial page. I was the guide for Senator Angus King in the middle there, Senator from Maine, and the Commandant of the U.S. Coast Guard a couple of years ago on the same kind of fact-finding trip, because there's big implications for what's happening in the Arctic to both national security and all sorts of issues around the polar ice cap. Anyway, I'm going to go long here, so I don't want to do that. What are the takeaways? I've got 5 or 6 slides, then I want to get questions. I think we're more or less on time here. Rising seas and shifting shorelines are a fact of life now. There's nothing we can do to stop it where it is. If we do the right things to reduce greenhouse gases, particularly carbon dioxide, and get serious, and we're not serious yet. Most of you know that. But if we can get serious about this and make this like a atom bomb or put a man on the moon project, if you will, we can keep it from being disastrous levels. we can keep the rate of rise to being something we can perhaps adapt to. And we really should try and do that. And we're not. Every inch of sea level rise makes a difference. And this is what's really confusing. When you think about the coast being vulnerable, you're worried about the next hurricane, you're worried about the next king tide, you're worried about a heavy rainfall event, right? All those things that can change the water level quickly. The sea level rise like the drip filling the bucket. But if you're at a point of flood vulnerability with storms coming or rainfall coming down the hill or whatever, the last inch is what decides whether you comes in your front door and your house floods or your car gets carried away, right? So it's the marginal inch that matters. And sea level is going to be higher inch by inch. So this is where it kind of challenges our time frames, because it can't rise much next year. If you're worried about flooding next year, forget about sea level. You should only be concerned about storms, rain, runoff, and king tides. There's no way sea level can add an inch next year. But if you're planning what your house or your community might be like 20, 30 years from now, yeah, sea level, because it's not going to rise smoothly. It's not linear. It's not even curvilinear. It's going to have those bumps like it did 14,000 years ago. We don't know when. What do? You do what you're doing tonight. You get educated. You learn facts. And again, I can defend everything I've said tonight, and I hope to your satisfaction. But talk plainly. We don't need to do mumbo jumbo. We don't need to bury people in too much jargon and facts. We don't need to bring in all the other ocean issues, which are really relevant, from manatees to corals to the choked waterways and stuff, which are really problems. But if we're talking about sea level rise and how to slow it, let's stay on topic for 1 hour. It's worth that, because we need to change the shorelines. We need to re-engineer our coastlines. We need to change building codes. We need to do a lot of things. So you can talk to your friends, family, neighbors, business associates, your investment advisor, to elected officials. We should be revising building codes in anticipation of sea level rising. You should evaluate your assets, look at your percentage at risk, your age, your vulnerability, whether you're concerned about leaving something to the next generation. Decide how vulnerable you are and act accordingly. I've had people say, well, John, I'm 88 years old and I don't have any kids and I like to live on the barrier island. I say, fine. Live on the barrier island. Have a nice day, But don't expect the taxpayer to come and make you whole when your house falls into the sea. That's my opinion. Being more blunt, don't panic. Sea level is not going to be a problem next year. That's the good news. It's not like being ready for the hurricane Dorian that can show up 2 weeks from now. Assess your vulnerability. I've already said that. And as a general guideline, plan for the first 3 feet of sea level rise. When? As soon as possible. It doesn't get any simpler than that, folks. When you say, what does John Englander say about sea level rise? He said, plan for the first 3 feet as soon as possible. Because that's about as accurate as I can get it, because we don't know exactly how Antarctica and Greenland are going to melt. And we're getting fooled by the models and the numbers. We have models for everything, besides the physical models like airplanes and boats, but we have models for interest rates and how many people will die from flu and how many people will, and what the national economy will be like and population growth. They're models. They're not reality. They're just projections. Life insurance models how long you'll live. You've all been there, right? I mean, they say, okay, we think you're going to live to 94 years old based upon your, different factors. They're not saying you're going to live to 94 years old. You could die tomorrow in a car accident. You could get cancer or some terrible disease. You could live to be 104. The model said you'd be 94. So the climate models and the sea level models are models. Most scientists tend to get buried in the models. They forget that they're just models. They're getting better and better. What do? We can build cities that are more flood resistant, both for flooding events and also for sea level rise. This happens to be a city in part of Hamburg, Germany, a place called Hafen City. It's a new development. And they have terrible river flooding. The water backs up the Elbe River from the North Sea about 20, 30 days a year and raises 20 feet in a matter of hours. But being clever Germans, they have figured out how to engineer and have a very livable city. In fact, it's fantastic. It's growing terrifically. I was there. And it's a great example of creative landscape architecture and building codes. There's no habitable floor less than 20 feet above water level, because they want the sudden rise to be accommodated. But we can learn from that. Now, people say, well, this is too tough, we're never going to do it. We have no choice. If we'd been born 15,000 years ago, when sea level was rising by nature, according to the Ice Age cycles, we would have seen the water keep getting higher, and we would have never built that close to the shoreline. We would have figured out engineering techniques to accommodate a rising sea level. We got fooled. For the last 5,000 years, we were at the turning point. I'm going to do this from your side, but sea level was rising, and it was about to come down, so we were at the slack tide. Our 5,000 years of human civilization happened at the change between the water coming in the marina and about to go out, right? The water seemed to be stable for 5,000 years. That's why we got fooled. We now know better. You now know better. This is a really big oceanographic message that should not be lost in all of the other important oceanographic messages. So, I think we're right on schedule, almost 7:30. Still got time for 15 minutes of questions, and then we're going to go outside and sign some books and all that. I don't have that many books, by the way. I didn't expect this many people here tonight. So they're $20 each, and there's 20 of them, I think. So otherwise, you have to get them on Amazon. The Rising Seas Institute, I want to tell you about my work. This is what I'm going to do for the rest of my life. I've stumbled into this topic. I've told you how I got here. You know my kind of life history at the moment. I did not plan to do this. If it hadn't been for learning about sea levels in the 1970s, the talk with Cousteau, being in Greenland the first night and getting this aha idea to write a book, which took me a lot of time to kind of figure out, and then Hurricane Sandy proving my book correct, days later, making me a soothsayer or something like that, I wouldn't be here tonight. I had no plans to do this. I didn't even want to do this when my book was done. I was so tired of writing the book and the editing process, I couldn't wait to do something else. But then Hurricane Sandy happened. So that's why I'm here. And I found that whether I'm explaining this to general audiences like this, which I don't get to do very often, or to the Florida architects, or the British engineers next week, or the people in Singapore who are ahead of the curve, or San Francisco, each audience has its own kind of baseline and where they're coming from. Stewart's a good oceanfront, fairly affluent, semi-retired but working community, diverse ages. Some of you are retired, have the time to think about what you're going to do. I hope you take some of this message and teach it to others. That's your cost of admission tonight. Pass it on. Play it forward. Most people don't understand this. So my part, the next thing I'm doing, I'll have another book out this year. It's called Moving to Higher Ground. It's about adaptation. It'll be out later in the year. It should be in bookstores, hardcover and all that. The first one was not. It was just Amazon and softcover. But the Rising Seas Institute, I want to tell you about that in case any of you are interested. We are looking for some of our early founding donors. If you want to give us $20, we'd certainly welcome it, but the truth is we're really looking for people to help get it started as an operating institution with a dozen employees or so, to be able to work with architects and engineers and the planners and people like that who need to really understand this and take it to the next level. And so it's going to be a global resource hub, policy center, and think tank, as I said. Identify clear concepts in communication, like what I'm doing, but obviously drilling down a number of layers to give it to the planners and engineers and architects in a way that they can process it and apply it to what they do. But it also affects banking and finance and all sorts of things, national security. Countries will disappear. Now, the interesting thing is we didn't know, but that happened naturally. Again, sea level, the last time it was higher, as you saw earlier, was 122,000 years ago during the last warm spot in the Ice Age cycle. Sea level was 25 feet higher. Not our fault. That happened by nature. We didn't know that. So I think all of those things you can see are good, not only fact points for people, but emotional things to help us kind of process this and put it in perspective. But this time we are causing it, so we need to slow it. We need to be more resilient to events, flooding events and fires and so on. And we need to begin adapting to the change in baseline sea level. That's my sustainability, resiliency, and adaptation. I think that's it. Questions? Let me turn the lights up so we can see people.
Did you want to visit any of those other 5?
No, we don't have time. I've talked too much, which is usual. So, anyway, nobody left the room, so couldn't have been too bad. Thank you. Thank you. All right. Thank you. Is this still on? Yeah? Okay. I'm going to repeat the questions. Please keep questions short so we can get hopefully 10 or 15 in. I will hang around. Turk, my colleague here, is going to help me sell books and give you information about the Greenland trip. And if anybody's interested in finding out about the Institute, he's here to help. I'll start with you, sir.
Thank you very much. Scientifically can explain cycles of up and down, obviously before the last.
Okay. I'm going to expand the very short answer I hinted at, but you're going to have to read the book or go on my blog post and get it more detail, okay? But really simply, the Ice Age cycles were forced by the changing orbit. I'm oversimplifying this, but it's absolutely true. The changing shape of the elliptical orbit around the sun. So in that sense, just like summer and winter is hotter or colder because of our shape, our point in the elliptical orbit, the elliptical orbit changes shape over 100,000 years. So the ice ages are effectively a super summer winter. When the oceans get warmer, they release gas, according to a principle of physics. You can prove that. Again, I always teach you physics in a way you can do in the kitchen. Take 2 bottles of carbonated beverage, uncork them, the bubbles will come out, obviously. Warm one, it will go flat quicker. When you warm a liquid, it releases gas. So when the planet is warmer, by the orbital forcing of the sun being hotter, it releases carbon dioxide to the atmosphere. When we put carbon dioxide in the atmosphere, it does this greenhouse gas effect where carbon dioxide, a clear gas, traps heat. Okay, so that's the 2 forces. I hope that makes sense. Good. Okay, next.
Yeah, why did you mention the lungs, the Dutch and
I'm sorry?
the expert on this, pricing C.
They,
Why didn't you mention the Netherlands and
okay. Yeah, the Netherlands. Okay, so.
They're the expert. They've been pumping water.
Okay, thank you, sir. So he's asking about. Okay, thank you. He's asking about a place like the Netherlands and Singapore. So let me give you 2 quick examples. The Netherlands, and Singapore works with the Netherlands, actually. I was just in Singapore. The government is actually taking the leading position in Singapore right now. They're planning on 4 meters, 13 feet of sea level rise this century. They're building a new airport terminal 5 meters, 16 feet above sea level. They're thinking futuristically. But they're getting a lot of Dutch technology, as the man said. Now, it's misunderstood that the Dutch are experts in sea level rise. That's not what they're experts in. What the Dutch are experts in is for 1,000 years they've been reclaiming underwater property and making it land by building a dike and using a windmill 1,000 years ago to pump the water out. They create polders. So the Dutch are really good at building coastal defenses. But when they had a tragic storm 60 years ago, and 1,835 people died one night when a levee broke, they decided to build everything better. And you've seen the famous the big harbor gates at Rotterdam, those semicircular gates that kind of look like the Eiffel Tower on their side, right? Well, when they designed those hundreds of millions of dollar structures, they planned for the worst storm they could imagine, the worst rainfall coming down the rivers from the Rhine, the Schelde, and the Meuse, the three rivers which joined there in Rotterdam, and they allowed for 30 centimeters or 1 foot of sea level rise. Because when they designed the harbor gates and their coastal defenses, the worst they could imagine was a foot of sea level rise this century. So now the Netherlands is also struggling to figure out how to cope with the other. I think there's a political agenda there, but anyway, we'll let that go. I'm not sure what it is, but the Netherlands are also struggling to cope with what are they going to do when sea level gets 5 feet higher. They don't have that figured out, but they're excellent water engineers. Okay, yes, sir, and this first you and then you, yes.
The oceans have been.
Yes.
Is there a point at which they start giving back that CO2?
Okay, he said the oceans are a CO2 sink, means the excess CO2 is dissolving in the ocean, which is true. At some point, they give it back. It's because so much CO2 has been dissolved in the oceans because of our increasing CO2 in the air, less is going into the ocean, so it's slowing down. If the oceans warm more, they will also start releasing CO2 to the air. So both are true. Yes, sir, the green shirt in the back. Oh, great. Yes. Okay. When the ice sheets or ice caps, the ice on land melts, does the land rebound? Yes, it does. Very, very astute. And that's why Alaska and northern Canada actually are rising faster than sea level, and Scandinavia, by the way. So the place where the ice retreated last, about 10,000 years ago, is still having glacial rebound, or isostatic adjustment if you want to get technical, but the land is coming up at about a ½ inch to an inch a year, which is faster than sea levels rising a quarter of an inch a year. So in those places, it looks like sea level's falling. And it's another example of why we're so confused about this. Okay, I think there was one here. Yes? Yes. If we can get CO2 to zero, we will eventually slow the rate of melting ice and rising sea level, but not for 30 or 40 years. At least. Actually, not for centuries. It's like stopping the Titanic when they came out of the fog bank and they saw they were going to hit the iceberg, you know? I mean, we're too late to avoid impact. So, and one of the things I use it as a metaphor in the book, in fact, is imagine that you're on the Titanic and you just came out of the fog bank and you're going to hit the iceberg. I suggest there's 5 things you can do. You can party, say we're screwed, right? Some did that, okay? You can find out who's at fault, trying to attribute blame to somebody. Not much benefit of that at the moment either, okay? You can start to think about what you're going to do to minimize impact or damage to yourself. And you can begin to think of what's going to happen after the impact. Start planning for the future. And what you also should do is think, is there some out-of-the-box solution? That's what the captain should have done. And if I have 2 more minutes, I'll tell you an amazing story I only uncovered during the research for my new book. There actually was a solution to the Titanic problem. The facility that built the Titanic with the Royal Institute of Naval Architects did a study about 10 years ago. And they said, was there something else that could have stopped this accident from the moment it was seemed to be a foregone conclusion? Instead of turning to port and trying to avoid the iceberg, if the captain had turned a little bit to starboard and ran straight into the iceberg, the ship would have lodged. They could have gotten off on the iceberg and awaited rescue. A very thorough study was done. The point is, sometimes we're not thinking outside the box. The problem with sea level rise is actually surprisingly simple. We need to slow it as some of you have asked the questions, of course. We need to be more resilient to flooding events. And if we believe John Englander and others that the sea level is going to be several feet higher, and we can't predict exactly how fast, what should we be doing? We should build higher. We should not be building quite so close to the water. We should do things on floats, have more houseboats, have more RVs, okay, be able to adapt. I mean, it's really not rocket science. This is a lot easier in concept than putting a man on the moon. It's harder because it affects every inhabitant of the planet where they live. It's not a bunch of engineers getting men on the moon or building the atomic bomb. This means that all of us in our coastal communities have to think different. And we don't like to change the way we're doing things. We don't mind paying somebody to figure out how to go to the moon, but we want our house in the Florida Keys or, near the Everglades or wherever in the Bahamas. That's why it's a problem. We don't want the answer. Once you understand that as the ice melts on Greenland and Antarctica, that sea level will rise, everybody believe that now? Okay. So if you believe that, we've got to start building higher. For the first time in human civilization. It's surprisingly obvious. We just like the ocean where it is. We'd like it to stay there. But when people say that to me, I say, well, I'd like not to get older. I'd like not to die one day. We're working on that. Okay. Well, that's great, but let's do plan B as well. Yes. Okay.
Going through
You need to be more specific. The rate of water change. I'm not too sure what you mean.
for example, that we don't
Give me an example. You mean like saving the Everglades or something like that? Okay, good. Okay, so the question is, are there things we can do environmentally to retard the process of the ocean rising? No. Okay? I've heard, believe me, I get an idea a week thrown at me. Okay, we dig holes in the desert and, do different things like that. The physics don't work out. The size of the oceans and the volumes involved here and the trajectory of the ice melting faster and faster, it would distract us from the real solutions, okay, which is three things. Slow the warming by reducing carbon dioxide and get aggressive about it. Be more resilient to extreme events like flood events, which water comes and recedes, like a hurricane, and begin adapting to the new reality that sea level is going to be several feet higher. We have to do those three things while we're doing all the good environmental things, protecting the Everglades and endangered species and taking care of sea turtle nests and all these other good things, okay? The problem is if that distracts us, we can have four agendas at once. We can do all four of those things. Be environmental, work on slowing the warming, be more resilient, and be adaptive to change. One there, and then here, and I think we're still okay on time. Yes? Sure, we're getting more extreme events. We're getting extreme rainfall. We got 60 inches in a day in Harvey. Okay, nobody ever thought that Houston would get that much rain, okay? Wildfires from Australia to California, of course, in the news. So we're getting more heat, more rain, more drought, more snow. All of those things are happening as we're warming the planet. And those are all expected outcomes of warming the planet, okay? It seems counterintuitive or contradictory, but it's not. If you warm the planet, you will get more drought, more rain, and more snow, okay? Seems strange, but that's simple fact. So what do we do about that? The resiliency is to anticipate that the 100-year storm is going to get worse. We're now getting 100-year rainfall events every 2 years in some places. So our baselines need to be recalculated. We assume that over 100 years things would average out, but not if the planet's warming. So being resilient is to be prepared to endure or recover after an event. So the water comes in, the water recedes, and how do you continue your business? That's resiliency. But if sea level's risen 2 feet in the 20 years, that storm event's going to be even higher. So we've got to be resilient and also adapt to the new baseline of low tide or regular high tide, okay?
I have one question to wrap up with.
Okay, that's your prerogative, Zach.
So I read today that the fires in Australia, which are arguably linked to climate change, are dropping ash and soot on glaciers in New Zealand. And like your analogy of the black roof versus the white roof, that's potentially accelerating the melting of those glaciers. Is that a brand new story, or has this happened in the past where some sort of human-related darkening of snow is causing things to melt more rapidly?
Okay, good question. A couple of parts to it. So the glacier picture I showed you from, I think, Greenland, which had black on it, was from carbon that's come out of the air probably from the soot from stoves in India, is what they think, okay? Because they burn a lot of cow dung, okay? Now that's being converted to solar stoves and things, which is really good, and getting the carbon out of the air. So we've seen cases where there's different reasons for black carbon in the air, not carbon dioxide, which is clear. That's another point of confusion. There's 3 separate things. Carbon, which is visible black in the air, soot, smog. Carbon dioxide is a perfectly clear gas, as we know. We're exhaling carbon dioxide, totally different. Carbon and oxygen in a molecule. And then the ozone hole, which people confuse too, that's entirely different as well. That was caused by the spray cans and refrigerants, remember? The hole in the ozone. Those things all get confused. So it's a good example. We've seen some of this before, but we've never seen 410 parts of carbon dioxide in the air. And as you remember back to my 3-part, I'm sorry, I didn't tell you, well, there it is, slides at johnenglander.net. That's the closing point, I guess. If you want some of my graphic slides, send an email to slides@johnenglander.net. They're free. I don't do any of the names. There are no ads, okay? I want you to use them. There are about 12 slides to go out and teach this. It has that triple graph, and you can go back and study it, so that should allow you to answer that question.
Folks, can we get it?
No, I think we're...
I just want to say thank you guys, but especially thank you to John. Can we get a big round of applause for John?
Thank you so much. You're welcome. You're welcome.